recording. So first of all, let me say welcome to the IoT class, the new and revamped IoT class. And the reason why I call this a revamped version is this semester we are doing a capstone style project where you would just solely work on your projects, and hopefully you learn about IoT from doing those projects. And I'll begin by talking about the admin stuff, right? We have a class website. By the time you saw this video, I'm sure you already signed up, but if you have not, please do sign up. If you haven't got an email, you will get an email soon. So if you somehow go to this video from because you were checking out the research methodology lecture and you saw another video from my IoT class, and you haven't got an email yet about the IoT class website, wait for us. We'll send the website link so that you can join. This is where all the information comes from. This class is going to be posted, including our policy, the syllabus, the schedule, and any announcement, anything that related to the project, including some of the project ideas that we have for you, where you can pick from, right? So we're going to list potential project ideas. Some of them might have more details, some of them might have less details, but more room for you to design and engineer around how to get to the solution. There'll be actually the name that are tied to the projects. Basically, those are potential mentor. So now that I mentioned mentor, basically the whole easy program can potentially, one of us or multiple of us will be the mentor that advise your projects. For each project, basically, there can be assigned one or more mentor, depending on the scope of the projects. And your project, by the way, basically the policy is no plagiarisms, and please check our syllabus on the detailed policy. Let me expand a little bit more of a mentor, because while we are your mentor, the majority of what we can do is just advising. Everything else, your job. All right. So you're gonna build things on your own. If you run into something that's like, hey, I don't know how to proceed through this, we are going to suggest, okay, what can you do? What should you check out? What are the potential, like basically a high level guidance, so that you can actually troubleshoot on your own, so that you can actually seek what could be the solution for the problem you're seeking. Your grade will be based on the quality of your projects. We are going to ask for a weekly or bi-weekly progress updates, where you have to keep an updated journal on a website. And we're going to expand on this in a few more slides. Your actual project's code, we're going to check out your code. You need to have your own contribution to the project. We are going to ask you to put your code on GitHub from day one. From day one, I want to see the code start from a blank slate and see how the code shape up, right? How the code shape up from nothing. The projects have the quality of like a master level, basically graduate level class. So you submit a project that is equivalent of like a sophomore undergraduate projects, and your grade would tank, right? So please consider things like what's the technical difficulty, what's the quality of things you submit, especially for those of you who are not familiar with coding and programming. You are going to have to learn. All right. Your project is going to be, again, is a project-based class, so it should be something that are related to full IoT system. Feel free to put more focus on certain subsystems. That's fine, right? If you're going to use existing tools or frameworks, you must properly credit these previous works. Don't just install existing tools and call it a day. Otherwise, you're going to get 0, right? I will make sure of that. The project ideas are going to be available through the class website. And now I have mentioned about the class website and the project website. Let me expand a little bit on what do you mean by project website. Basically, every one of you must maintain a project website, one site per project, where we can go and check out what have you done this week. It should be updated weekly. We'll check the log. We are going to ask you to use github.io. It's free. You can sign up, and you can use a standard HTML to create your own website. It doesn't have to be beautiful. It just have to be readable and traceable and see what is going on with your project. What did you learn? What did you get stuck on? What are you trying to build this week? What part of the design you're trying to work on? And also, so they can check out your friend's work as well, right? So this is basically where you can have like a good idea, like where are the other, like basically what's the progress of the other projects? How, like, are there anything that you can brainstorm and like try to tackle problems? Any common problems that are spawning from like a fundamental computer science problem that you can maybe hopefully basically brainstorm, discuss, right? But again, there's a don't plagiarize. Don't plagiarize. All right. We will check the log because it's GitHub. We will see the update logs, and we're gonna check that, right? No late assignment. Again, we check this timestamp. This year we have a lot of problems with you guys submitting things late, right? And because I'm a part of this class, I'll make sure I don't tolerate late assignments. So I'll make sure that's being imposed to some degree, if not strictly. It depends on the class policy and the syllabus. So go and follow the syllabus, whatever is said there, go with that. All right. And every project must maintain your code on a GitHub account as well. If you want to make it a private repo, feel free to do that, but make sure you include us so that we can check your code. Right? I want to see updates and see who make the updates. That's strictly required. All right. So you can, so that we can trace and track what's going on. Okay, so now we're done with the admin stuff. Let's actually talk about what is IoT, right? What does IoT really mean, right? Because you might have heard this word a lot, right? You've seen things like this device, right? The Echo Dots, right, from Amazon. What does it do? It's basically it's a speaker, right? It does connect to the internet, and it does connect to Alexa service, which you can ask them to do certain things like play music, for example. It's not connected, so I cannot do that right now. But it allows the user to interact with the device. Is that IoT? It's part of it. My question that I'm gonna ask you, right? So you might have also seen another example, like things that would allow you to control the light in the room, turn on and turn it off. Whatever people call quote unquote smart meter is just basically meter connected to the internet. Is that IoT, right? And the answer I'm going to give you is basically IoT is just a keyword, right? So what's the difference between IoT if you compare that to like a modern computing system? Because there's not a lot of difference. There's certain distinct differences, but if you think about it the other way, isn't this just a bunch of computers connected with each other, right? So fundamentally it's a bunch of compute devices that can do certain purpose, it can serve certain purposes for certain application, and they are connected. Do they have to be connected to the internet? No. And that's actually one of the major misconceptions. Internet of Things. If you break down this word, it's an interconnection network of things. It doesn't say internet. It doesn't have to connect to our internet that we're using. But the things that are connected, right? You have to have some way to communicate between multiple devices and make sure they operate based on whatever you program them to do. So if you think about it, if you especially for those of you who study in computer engineering, computer science, it's a conglomerate of multiple topics. It's actually multiple fundamental topics that are mixed. And the way I would characterize this IoT is the one that's closest, right? The area that I would say closest to the word IoT is distributed system with heterogeneous node. What is distributed system? Distributed system is where you connect multiple, where you have multiple systems, when you have to make sure they connect somehow and make sure they operate in a distributed fashion. Each of these subsystems can be different types. It can be sensor, the do certain things. It can be your computer, it can be your a server in the cloud, right? And is that it? It's actually not. Right? As I said, it's a conglomerate of multiple topics. So I'm going to compare IoT to, for example, embedded system. Is embedded system IoT? My answer is no, it's not IoT. So if your project is like, I'm just going to program something in Arduino, I'm going to make sure that, I mean, those are not IoT. It's just coding on embedded system. It's different, right? So creating just one thing to drive one single embedded devices, no, it's not IoT. You can't just say, hey, I'm going to build a smart like a meter that can measure the voltage and current and call that IoT, because those are not IoT. If I have them connected to internet, do I still call that IoT? No. There's elements of IoT that's actually expand upon the topic related to this, right? But embedded system is a big part of IoT. It's actually a really big part of IoT because your device in this IoT system can have small things like Arduino or Raspberry Pi. These are small computers that you can program and talk to the sensor, things like the temperature sensors, the humidity sensors that you can read and somehow process those data, right? And embedded systems also include things like I can write the device operating systems because they are small, so you want to be as efficient as possible. You can deal with device communication. How do you deal with noisy reading? So for those of you who are in communication engineering, you might want to consider, okay, are there tricks in discrete Fourier transform or anything that are from your signal and system class that you can use to deal with these incoming signals, which sometimes can be not as accurate as you would have hoped for, right? Using math to solve problems. We have been doing this for years and years and years as a human species, right? A good system would involve tons of assembly and system hacking. So IoT would integrate both embedded device and occasionally, actually for most of them, to be honest, there'll be some server, the more powerful computer that would do complex data processing tasks, right? And it also requires a system to kind of manage all the devices. So it's actually, that's why I say it's expand upon beyond embedded system. For those of you who took distributed system class before, I would say this is essentially the same thing, but some of the differences, distributed system, like a traditional distributed system would assume things like a server, a cluster of computers. So it's a compute devices that looks the same and they are like their server, right? They're powerful device or even workstation. But when you look at IoT, these are distributed systems that integrate multiple types of nodes. It can be something from your sensor up to your server, right? Some of the server is actually kind of being abstract into the cloud, right? Function as a service. But those kind of compute resources in the cloud they can run, right? You can also have things like edge device where you have the like NVIDIA Jetson Nano that connects to the sensor, or just literally sensor that stream data, or Raspberry Pi that has, and all you might have noticed if you're coding quite a lot, you might have noticed these things are different architectures. Some of them use the traditional Intel x86 that are similar to your server, to your computer that you use in your laptop, right? Some of them use, like the GPU use NVIDIA CUDA. Some of them, like Raspberry Pi, would use ARM, which is a totally different languages. How can you deal with these different languages, right? Also deal with the edge node, which is one of the key thing in IoT. How many devices you're connecting, right? Scalability is a big problem in IoT. I think it's a big, often forgotten problem that I can say is gonna basically destroy many IoT systems if you cannot build it to scale, right? To scale from 1 to 2 to 3 devices to 1,000, 10,000, or 100,000 different edge nodes that are computing, right? So now that I talk about scalability, I need to talk about What about computer network? What does it have to do with IoT? It does have a lot to do with IoT because they have to connect it somehow. The device have to connect, right? So it's a huge part of IoT. How do you want to integrate all the device? How do you want to send the data? How to secure important data? How to secure the system so that no one can hack to one of the device and read the data, right? Dealing with multiple OS, operating systems, and ISA would make the problem a lot harder, right? It's a lot harder than you think because they think of it as it's different language, right? It's like when you're trying to manage a room that has people that doesn't speak one common language. There'll be a room that has Thai people, um, Indian people, Chinese people, and people from European countries like from the England, Spain, France, Germany, and then people from the US in that one room, and they don't speak their second language. Fun, right? The Thai people would talk in Thai. Indian would talk in Hindi, and the Chinese would talk in Mandarin, right? So it's gonna be kind of hectic, right? So inside the network that look like this, how are you gonna manage them? So it's actually a big problem. How do you abstract away the communication, right? It's like when you have human talking in different language, but you still have your hand gesture that you can use to kind of infer information. All right. So things that you want to keep in mind is you're gonna go through multiple topics that are fundamental to CS. Quick warning, I have to say ahead of time, this is going to involve quite a bit of coding. So if you're from CSE, EP, or SGE students, and if you haven't coded in a while, or you never code or program at all, you're going to have a lot of difficulty in this class. But it's not impossible. I do encourage you to have fun and try. So you might not have a lot of background on most of these topics. From my experience is sorry, but this is still the old name for the computer engineering program. So for the computer engineering students, from my own experience, you also have a lot to catch up because you guys tend to don't have a lot of background in computer systems and computer network. So talk among your friends. And my recommendation is make sure you're at least comfortable with Python, C, and C++. At least a bit like the sophomore level kind of class, right? These are the requirements. Otherwise, you're gonna instead of having fun, you have fun, but you're gonna struggle in this class and you will learn for sure. This is a great thing. You want to learn. So I do encourage that, but this is a warning. You have to actually catch up, right? All right, so now that I talk about the really brief overview and compare against different area in computer science, right? So let me talk to you and talk like say basically what I think about the IoT system. So this is a high level, right? I'm gonna use the figure I draw. I'm gonna label E as an edge device. This can be like my phone, for example, or it can be like a thermostat, right? And then you can have things like a desktop. So if you look back in the day without the IoT systems, like look at computer system in general, right? So we humans start with desktop, like basically that's your most of us first computer. You buy a desktop, right? And one thing you can do is you can make them connect, right? So that the two desktop can talk to each other, or the two mobile phone can talk to each other. But then we discover internet, which basically means that you can have multiple other information on a server hosted somewhere in the world, and the desktop can connect to it. There can be more server, more information that are available in the cloud, right? So this server can be in the cloud. You can connect to them. You can choose to have your own private server. It's not connected to the cloud for things that are crucial, and you don't want to actually connect in a way that no one else so maybe connect in a way that you can only solely access these things, all right? Or it's a local server, that's also possible. And then you can have edge device. There's like Arduino, Raspberry Pi, Jetson, and they can be connected, all connected, right? And then sensor reading like a temperature, wireless. For example, Wi-Fi can be connected to desktop and the edge. You can have headphones connected to your desktop. Your webcam can be connected to the edge device or the desktop or your mobile, right? The camera on the mobile phone, right? And these are basically things that are in your IoT. So for those of you who are from the embedded system background, that's why I said it's not all just embedded system. It's actually many more things, right? And you look at this diagram, basically you can kind of look at, hey, there's a multiple classes of computer in the IoT, right? So you look at this, basically server-grade computer that has multitasking, multi-user computer, like Unix-based computer. These are, for example, Ubuntu, Linux, or it can be like Mac OS well, Mac OS is actually more desktop kind of computer. You also have a user-grade computer, like a mobile and desktop, right? Just directly interact with the user. It can perform a lot of computation. They would connect to the server most of the time, and that's why the server has to be multitasking, multi-user. Multiple people are connected to the server. They want to use the server. This is a powerful machine, right? And then you have edge devices, wearable. For example, the Apple Watch that I'm wearing right now, right? That can read my my health-related data and basically yelling at me that I haven't walked or worked out in a long time. Sorry about that. Work from home, right? So these are edge device. Sometimes we call this wearable. Yeah, I mean, it's wearable. So there's something you can wear it with you, right? And you have sensor that reads data and just send out data. It typically has to be controlled by some other computer, all right? And basically, these IoT is like you put these things together, right? So the question that I'm gonna make sure you ponder upon this, and especially when you go into your project, is like, who should be the one managing all the devices? Are you gonna have like multiple manager and that are talking to each other in a hierarchical fashion, or one single global manager? What if some devices are not reliable? What do you do? What if I take one of the node out? Would that crash your system? What if the network is not reliable, right? Because many of these devices somehow can be relying on 3G or 4G signal. And as you can see, it's just 3G and 4G signals are not completely always there, right? Think about self-driving car and you drive in a like really rural area, right? What's the chance of like you go in there and there's no internet signal? This is possible, right? So what do you do? How do you distribute all the computing tasks across all these devices? This is a big problem. I have really tiny embedded devices, and I want to make sure they can compute something meaningful. I can actually send the program to another device. Hey, you're free. You can look at your computers and send the results back to me. You can actually try that, right? It can make your performance better. But how do you do this? What's the policy? How do you synchronize all the communication? So if you program in multi-threading fashion before, think about what if you have to do multi-threading, but for different devices, or multi-program, but you have to synchronize somehow, right? This can be something that can be a headache, but it also enabling you to do a much more powerful things with the concept of IoT. How do you send data through and from different network, right? So basically that's it for the introduction. I'm gonna have the basically next set of slides. It'll be about Git and version control. It's gonna expand on what we require you to work with, right? So that we can look at your code, look at the logs, look at the updates, and grade your projects. So I'm gonna first stop the video now so that I can have a separate video focusing on Git and version control. So I'll upload this video and you'll see another video that talks about Git in a bit. All right. Thank you so much.